So now we are moving on to further polygons, and the first one is quadrilaterals, and some of the main quadrilaterals, their details I'm discussing over here. The first quadrilateral is a rectangle, and this is formed with a pair of two pairs of parallel sides. Opposite sides are equal in length, and they have the same direction. Important thing to remember is that all the four angles in this quadrilateral are right angles. So this is something very important about rectangles, which makes them different from other parallelograms, quadrilaterals. The two diagonals are equal in length. Diagonal is a line which is made by joining two opposite vertices. For example, BD and AC are the diagonals of this rectangle. Diagonals bisect each other. So basically, when the diagonals intersect each other at a point, this point breaks this diagonal into two halves. And the same is the case with the other one also. Now, the next one is a square. Again, two pairs of parallel sides. All the four sides are equal here. Not only the opposite side, but the other sides are also equal. All the four angles here also are right angles. The two diagonals are equal in length. They bisect each other at right angles. So this is how this is represented. And diagonals bisect the interior angles into two parts. For example, this angle A is 90 and this angle T is also 90, and they are interior angles. So their sum is 90 degree, as you can see. Now the diagonal has bisected this angle. So this would be 45 and 45. The same is the case with the other diagonal. So the angles are bisected and broken into two equal parts. The next quadrilateral is a parallelogram. These are again two pairs of parallel sides. Opposite sides are equal, and the angles, opposite angles are equal, but they are not right angles. If they become right angles, then it would become a rectangle rather than a simple parallelogram. Diagonals bisect each other the same way as we have seen before. Next one is a rhombus. Two pairs of parallel sides. All four sides are equal. Opposite angles are also equal, like a parallelogram, but the angles formed at A, B, C, and D are not 90 degrees. Diagonals bisect each other, and they bisect at right angles. Diagonal bisect the interior angle and break them into two equal parts for this quadrilateral also. Trapezium, one pair of parallel side. AB is parallel to CD, while AD and CB are not parallel. So nothing else important here. Kite, the opposite sides may be parallel like this. They might be parallel, they might not be parallel. There are two pairs of equal adjacent sides. So AD and CD are adjacent sides because they are connected at a point and they are equal. Similarly, AB and BC are also equal and they are adjacent sides. Diagonals can cut each other at right angles. So for example, one of the diagonal would be BD and the other one is AC. So they cut each other at 90 degree. One diagonal bisects the interior angle. So one of the diagonal over here, which is the vertical one, is bisecting the angles, this one. So these are a few important types of quadrilateral that we need to remember. The figure shows a parallelogram ABCD where ADC is 108 degrees. E lies on BAB such that BCE is 38. Given that ABC is 9x degrees. So this angle over here, ABC, is 9x. Find the value of x, find DCE. The other thing that we need to find out is this angle, DCE. Now, since it is a parallelogram, so we can see that the opposite angles of a parallelogram are equal to each other. Using this relation, we can find out the value of x in this part. And the abbreviation for this is opposite angles of parallelogram. This is how a parallelogram is written in abbreviation. So x would be equal to 108 divided by 9. So 12 degrees would be the answer for x over here. Now, to find out the other angle DCE, we can see that these two angles, 108 and this whole angle, are interior angles because they are being formed at two parallel lines. So these two must be interior angles, and DC is acting like a transversal between them. So I can write over here, so angle ADC plus the second angle DCB. Their sum must be equal to 180 degrees because they are interior angles and the lines AD and BC are parallel to each other. So it is 108 degrees. We can break it into DCE plus 38 and their sum is 180 degrees. So angle DCE is found out by subtracting 108 and 38 from 180 degrees. So its answer is going to be equal to 34 degrees.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.